For the quadratic model, I'm going to look at this example. This example, you can find the video from my math lab, and the person there did it for you nicely by hand, but he also went a little bit over how to do it with the calculator, but not everything. So I wanted to show you how to do this problem using a calculator. So first, a ball is projected directly upwards from an initial height of 100 feet with an initial velocity of 80 feet per second. Well, in my class, I'm not going to let you worry about how to write the equation. So here when it says find the function that describes the height of the ball, I'm going to explain it to you, but I will not, be expecting you to always know it. When things are given as feet per second, then the equation is always going to be negative 16 t squared. That comes from 1/2 of the velocity, so acceleration, which is the gravity. So again, don't worry too much about it, that's physics. Then plus always the initial velocity times t plus the initial height, which is 100. So in my class, in my problems, in my tests, I will be giving you this equation. So now let us see what we can do with it. After how many seconds does the projectile reach its maximum height, and what is that maximum height? Again, we know it's a second degree polynomial. The sign of the leading coefficient is negative, so we know it's a parabola that opens down, and that means there will be a maximum. Anyways, let us look at the calculator. Oops, my battery is low. Okay, so let's see. Hopefully this is a good position. So the first thing we're going to do is we're going to go to y equal and enter the equation, which is negative 16x, of course, not instead of t, squared plus 80 x plus 100. Now if you push graph, depending on what was the last time you used your calculator for and the window, you can see that the window is really bad. All we could see is a line. That doesn't make any sense. So we need to fix the window. Here's your window, and what we do is the x-axis is the time, so there is no negative time, so I'm going to make it 0. And I will go to like let's say 12. We'll see if that's enough for the time. And the y-axis represents the height. Now if we start at 100 feet and we throw the ball up, so obviously it's going to go really high. So, and also the calculator is going to talk to us in the bottom here. So we need to leave some negative. So I'm gonna try negative 100 to 350 for this problem. And the scale, let's make the scale big so we don't get lots of lines. Let's see if I like the graph. Yeah, I like it. Actually, that was too much. You know what? Let's be perfect. That's too many x's and there's too many y. So I'm gonna go back to window, and I'm gonna make it maybe 8, and instead of 350, how about 300? Let's see how that window. See, don't be afraid of playing with your window. Now the first question is, after how many seconds, like we said, will it reach its maximum height? So it's the vertex, it's this point. So what we do is we go to second calc, which is calculate, so which is in the blue. So you go to second trace, which is calculate, and you'll see there's a maximum. Go to the maximum, or you can push 4 and hit enter. Now the calculator will ask you what is the left bound. So to go to the left bound, use the left arrow to go a little bit to the left of where you think it's the maximum height. So that's good enough. Hit enter. It's going to ask you for the right bound. Go a little bit to the right of where you think it's the maximum. Hit enter. It's gonna ask you want me to guess? Of course we want you to guess. Hit enter, and then you're gonna see the maximum. That's the X and that's the Y. And what does that mean? That means after 2.5 roughly seconds, the ball will be 200 feet. So let me write that down. So we're gonna say after about what did we say? 2.5, yeah. After about 2.5 seconds. So we need the units. The ball will reach the height, which is the maximum height, which is will reach 200 feet. So that's the first part. Now for the second part, it says for what interval of time is the height of the ball greater than 160. So let us show you how we do that. So we want to know where is the interval of time where the height of the ball is more than 160. So we're going to go to y equal, and under y2 we're going to put the 160, and now we're going to graph again. So what we need is this interval of time from this point to this point. That's the interval of time where the height of the ball is more than 160. So how do we find these 2 points? Go to, again, second trace. Everything is there. Everything we do is there. Then you find number 5, which is intersect. It's going to ask you, is this the first curve? And it shows you a curve. Of course, say yes. Is this the second? Yes. Do you want me to guess? Yes. So in our graphs, we only have 2 curves. So we only need an intersection of 2 curves. So no matter what, first time, all you need to do is enter. Because yes, it's the first curve. Yes, it's the second curve. There's only 2 curves. Then yes, you want the answer. So the left side is 4 approximately. Of course, most of these problems you'll be asked to give to the nearest something. So let us say nearest hundredth. So now the second part here is 4.08. So nearest hundredth. So let's see now, what do we do to find this point? So if you do it again, if you do second trace again and go to the intersect again, if I hit enter, it's gonna give me the exact same point. So let's see what we need to do second time around. Go to second trace, number 5. Before you say yes for the first curve, use the arrow to go beyond and closer to the second intersection. So you use the arrow to go away from the first intersection. Now, is this the first curve? Yes. Is this your second? Yes. Do you want me to guess? Yes. So enter. And we see that to the nearest hundredth is 0.92. So this is the interval of time between 0.92 seconds to 4.08 seconds. The height of the ball is more than 160. Now for the third part, it says, after how many seconds will the ball hit the ground? Well, it hits the ground when the height is 0. So in our graph, where is the height is 0? It's this point. How do we find it? You go to, again, second trace, and number 2 is the 0. And here they're going to ask you for a left bound. You can do 2 ways. You can use the arrow to go a little bit to the left of the point, or let me show you another way. If you can count these dashes, which in our case they represent 1, you see that it's 1, 2, 3, 4, 5. This is kind of maybe before 6, maybe after 6. So let me say 6. Oh, it might be the exact answer though. Um, it's not good for this graph, so let me do it again. Go to 0, left bound, so you go a little bit to the left, meaning above the 0, and hit enter. It's asking you for a right bound. With the arrow, go a little bit to the right of it, hit enter. Do you want me to guess? Enter. So it was very close to 6. It's 6.03, but we said to the nearest hundredth. So we will say that it will hit the ground after 6.04 seconds. And that's how we use the calculator to do these problems.